Alright, so we're back. The Leetcode series. So unfortunately yesterday I was not able to do anything. I'm kind of disappointed for not doing anything. But I was just out with some friends catching up and stuff, so I mean it's not like I was just bumming around, like I was out and about doing stuff. Um but yeah, I should be back on it now. It might be harder now though, because I started working like full time, so that's like 40 hours a week gone. Um, but yeah, we're just gonna pick up where we left off, um, which is we finished these palindrome problems. We did an extra palindrome problem yesterday too. So now we're gonna do merge a sorted array, um, which I haven't actually looked at yet. So okay, it's an easy rank problem. So you're given two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n, representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. Okay, that's a weird way to just say like ascending order. But it's interesting, like these are the arrays they give you are also in non-decreasing order. So these two are in ascending order. And then merge them, the final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Nums2 has a length of n. Okay, so basically we need to take the elements in nums2, and I guess sort of insert them into nums1. Okay, that's interesting. So my initial approach, right? Well, I guess I'll just code it up. Also, I will say I'm gonna try to keep this episode short. It's already kind of late, and I need to start like waking up early in the mornings. So, because it's already 11, I'm trying to sleep soon. So, this will probably be the only problem I do in today's video. But here's my initial solution, right? So we'll say p1 equals 0, p2 equals 0. You basically just create a pointer on each array and sort of increment 1 as you move along the array. I don't know if that makes sense, but let me just show you. So we need it. What's interesting is we need to insert nums2 elements, right? So we need to sort of iterate through both arrays at the same time. So we'll do while for I guess we can do a while loop, right? While p2 is less than length of nums2. And then I think what we need to do is compare nums1 p1. So if nums1 p1 is greater than nums2 p2. Actually, we need to check if it's less than nums2 p2. So we want to insert this 2, right? You get to this 1. Actually, no, we need to do greater than. Because once we get to this 3, we know we have to insert it here. right? So then nums1 dot insert p1 comma p2 or nums2 p2. Sorry. And then once you do that, we can do p2 plus equals 1, and then p1 plus equals 1 as well. So the interesting thing is we have to make sure this pointer still stays intact, because so if we have this 1, 2, 3, 0, right, and we insert a 2, then it'll become 1, 2, 2, 3. But even though we still just inserted on the 3, we need to keep our pointer on the 3. So that should work. If we insert a value, we're still incrementing the pointer to compensate. So I feel like that should work, right? Let me think here. Here's the thing, right? Once we get to the 0 values, then we know that we can just start modifying, or we can just start replacing these. Like, we don't actually have to like insert and shift anymore, right? Or do we? Those all should be ignored, right? Okay, yeah. So we don't want to just insert and push these to the end. I think what we needed to do is we need to pop these zeros off the end as well, basically. I don't know why it took me so long to say that. Nums1 dot pop. So we just pop off the end, right? I feel like that should work, no? Let me just print nums1 and see what it gives. But I feel like this should be, oh no, list index out of range. Oh yeah, this is what I was talking about earlier. We're incrementing P1, but we're also popping from it. So let me just sketch this out real quick in my notebook. I'm not gonna do it on Sketchpad. It's gonna take too long. Okay. So we have 1, 2, 3, 0, 0, 0. And we need to add 2, 5, 6. Okay, so when we add the 2, we then get 1, 2, 2, 3, 0, 0. And I thought after inserting the first two, P1 points at a 3, and P2 points at 2. Then it increments to P3, right? We pop off the end, or we insert and then we pop off the end. So now P1 is pointing at the 2. But it should be pointing at the 3 now. Let me let's see. How is a list index out of range here? Nums2 is P2 out of range? No, it should be out of range, right? P2 should be less than 3, so shouldn't get to 3. Let's just print here, honestly. I just want to see if our insertions are even working. Because I don't even know if that itself is working. What? How is it just out of range on the first try? I'm actually so confused right now. What? Like, what does that print? It's not even get. Oh, okay, wait. So yeah, it does insert that. I'm also confused. It's like, why? What index is out of range? It has to be P1 that's out of range, right? Like, surely it's not P2 that's out of range. Huh. Well, it last prints 3, 1. So how is 3 out of range? How is 1 out of range? Wait, hold on. Nums2 is not getting modified, right? Just so I know how insert works. Yeah, right. How did that happen now? Oh, view more. Oh, I wasn't even looking at the full output. Oh, so okay, I see what happens. We get to the 0, and well, it's not less than 0, so it never actually inserts it. I see the problem. Okay. I see. Okay. So these is N and M are actually pretty important. Um, I wasn't using them before, but it's important. Um, um, what do they do? Like, why is it? What? How do we deal with these zeros at the end? Um, okay, I think what we need to do is we need to check P1. Because once P1 crosses M, yeah, so once P1, if P1 is 3, right? Okay, so if any, okay, P1 is greater than or equal to M, this is we just overwrite the zeros. Nums1 at P1 is equal to nums2 at P2. Then I do P1 plus equals 1, P2 plus equals 1, and then this is an elif. Okay, well, we don't really need that, right? But, yeah, okay, now there's no popping. Now we just straight up override it. How did I skip over the 3? 0, 1, 2, 3. P1 is here. Oh, I see. I see. So it just needs to be past the original element minus the number of insertions that we made. Okay, this is really scuffed, but right? Or actually plus inserts. No, minus inserts. Yeah. inserts plus equals 1. Yeah, that is a really scuffed way to do it, I think. Who knows? It never works when I try testing. Okay. How is this running so fast? If I have... Okay. Well, the runtime is 0 milliseconds. What's the time complexity of my code? I feel like, well, we're doing a lot of insertions, right? Like, worst case, it could be kind of a lot. It could be like O of n squared. Yeah, O of n squared solution. So, it said it's possible to do O of n plus n solution, which is a more interesting approach to me. So how do we approach that, right? Well, I'm thinking if we have a external array, like why do we have, if it was an external array, then it would be easy to do it in O of n plus n, right? Because you just have 2 pointers and you just compare the values, whichever one's lesser, add that to the array and then increment the pointer on that array that you just added from. But it wants it to be in place. Right? Let me just, wait, hold on, let me just try something. I really dislike the solution I came up with, but I mean, it works. Um, um, well, P1 is less than It would be so much easier if they're just equal length. Why do I have to think about this so much? Oh my god. If nums1 p1 less than nums2 p2, then we add p1, so new idx equals nums1 p1 idx plus equals 1 p1 is equals 1. It's not what I meant to do. problem is like this code isn't gonna work because we have to get these indices right. I hate working with like array indices. It's so annoying. You're always just off by one or some stupid thing. Okay, so what we need to do is if idx is greater than okay, yeah, we can just do this. P1 is less than m, then what happens? If P1 is less than m, that means n was smaller. N was smaller than m. That should be or. Wait. No, that should be and. Because that'll break. P1 is less than n. Copy remaining nums1. Oh, I know. Yeah. Let's do another while P1 is less than m. And just do. See this. Now while P2 is less than n. Right? And then do we not just do nums1 equals new? Where did I define nums? Whoops. What did I do wrong now? How is that out of range? Do I even need an index? I don't even need this. Let's say new.append. Okay. Forgot I'm not working with Java, so I can just like append stuff, you know, I don't have to keep track of an index. I'm so used to arrays being like fixed sizes. Oh my god. Bruh. What am I doing? Oh, okay, yeah, I'll remove all the IDXs. Why did I get it wrong? Why did I get 1, 2, 3, 0, 0, 0? What? If P1 gets over here, the list should just terminate now. Here, let me print you. Let me see something. Oh, this one. Okay, so that works, obviously, right? Yeah, see, that's the problem. What is the O of m plus n solution? I want to know. Uh, how do you keep it all in the nums1 array? Because, like, you don't want to overwrite values. Honestly, you know what? I'm not sure. And I think that's okay. Yeah, I mean, we did solve it. How do you do it? I want to see the O of n plus n. So let's look at this guy. I do not want to watch a whole video. Where's the time complexity? What is mid-x and mid-x? Last element. Okay. Okay. Mid-x is non-negative. Ah, okay. I think I kind of understand. Maybe, right? So you have this, right? And what you do you start at this 3 and you start at this 6. And you compare them and you're like, which one's greater? And that's going to be the max value out of both of those. So you just put that there. You just put that 3 there. Right? Or in this case, you just put the 6 here. Then you move to the 5. And then your right pointer goes here. And you compare that with that, and 5 is still greater. So you put that there. Now you're on the 2. The right pointer's here, this one's here. You compare the 2 to the 3, right? You compare these two. 2 is less than the 3, so you know the 3 goes here, right? And then your insert pointer goes here, your other pointer goes here. Okay, that makes sense. But when the 3 moves, do you have to replace it with something? You know what? But that is a problem for tomorrow. So I need to go to sleep now. So, yeah, we're done.